The global transition to clean energy is often visualized as a frictionless digital grid powered by sleek, quiet technology. But the physical reality required to build that infrastructure demands massive, relentless earth-moving. As a baseline, the global economy currently relies on the extraction of 17.9 billion metric tons of materials every single year. To put that scale into perspective, the industry moves the equivalent mass of 1,000 Great Pyramids of Giza annually. This brings us to a harsh mathematical paradox. Meeting the Paris Agreement climate targets requires tripling our annual demand for transition minerals to over 30 million tons by 2050. While circularity and recycling protocols will offset some of this burden, they cannot bridge the gap. A massive, rapid expansion of primary mining is an inescapable reality. For this expansion to happen, the industry relies on a social license to operate. This means that local communities and host governments must implicitly consent to these disruptive operations in their backyards. The severe physical impacts of breaking ground and scaling up extraction directly threaten that consent. When communities push back against environmental degradation, it leads to protests, strict regulatory crackdowns, and sudden supply halts. If capital markets do not govern the environmental and social consequences of this expansion, supply chain instability will likely compromise the very transition the world is trying to fund. This required expansion is actively redrawing the global map of resource extraction, pulling operations away from historical hubs. This chart details the specific commodities driving this shift. We are not talking about traditional bulk materials like iron ore or thermal coal here. Elements like lithium, cobalt, and graphite are the non-negotiable chemical building blocks required for battery storage and electric vehicles. Unlike traditional mining, the workable reserves for these critical minerals are regularly found within highly regulated mining jurisdictions like Australia or the US. Instead, the extraction is rapidly moving into fragile jurisdictions. These are states characterized by weak central governance, inconsistent regulatory frameworks, and high institutional corruption. This visualization overlays the two datasets. An estimated 70 breaking ground in these sensitive, remote jurisdictions requires an immediate, aggressive physical footprint that rapidly destroys intact ecosystems. This creates an immediate climate contradiction. The mining operations necessary to save the climate currently account for 4 to 7% of direct global greenhouse gas emissions. When you factor in Scope 3 indirect emissions, such as the coal-fired power generation used in mineral processing, the sector is responsible for up to 28% of total global emissions. Beyond the atmosphere, the terrestrial risks are just as severe. The new geography of transition mining places operations squarely inside critical natural habitats. This chart illustrates the ecological conflict. Exactly 29% of identified transition mineral projects overlap directly with designated key biodiversity areas. The human geography is even more concentrated. Over 50% of these projects are located on or near the established lands of indigenous and peasant peoples.
Operating in these territories requires strict adherence to free, prior, and informed consent, or FPIC. This is the international legal standard mandating that indigenous communities have the right to give or withhold permission for projects affecting their lands. When FPIC and baseline labor rights are ignored, the human toll is devastating. This is especially prevalent in the artisanal and small-scale sector, which is heavily associated with hazardous manual extraction and forced labor. Without securing actual consent, operators face inevitable community resistance. This translates directly into project blockades, frozen assets, and a total loss of the social license to operate. Industrial negligence accelerates this outrage. The sector averages 5 major tailings dam failures every single year, releasing massive volumes of toxic waste and decimating the surrounding landscape. Ignoring these localized social and environmental externalities guarantees a cascading failure across the sector, one that will ultimately choke off the global supply of transition minerals. Since host nations in fragile jurisdictions often lack the capacity to regulate these impacts, who actually holds the leverage to force the industry into compliance? Simply divesting from mining is an impossible strategy if we want an energy transition. Institutional finance must deploy active, aggressive stewardship.
To do that effectively, investors must map their financial influence directly onto the physical life cycle of a mine. We start at the very beginning of the timeline, during the exploration and feasibility stages, where the most important structural and environmental decisions are locked in. Institutional investors must apply intense pressure on the private equity firms, venture capitalists, and streaming companies that supply the initial capital for these early phases. This targets the junior mining companies. These smaller, highly speculative firms dominating early exploration must adopt rigorous environmental and social standards before their projects scale. Next, capital pressure must follow the project into its longest and most capital-intensive phase, operations. In this phase, listed equity investors hold the leverage. They must mandate that multinational mining firms strictly manage their massive waste output and their water usage. The data demands this intervention. The required end state for 2030 is clear. We need a sector capable of meeting society's massive material needs without driving regional conflict or breaking planetary boundaries. Individual investors, acting in isolation, cannot dictate terms to an industry of this monumental scale. The Global Investor Commission on Mining 2030 mandates collaboration. Investors must develop harmonized expectations across the value chain, paired with hard financial incentives, lowering the cost of capital to reward best practice operators and penalize those falling behind. This requires patient capital, long-term financing designed to absorb the heavy upfront costs required to implement high social and environmental standards from day one. This integrated approach uses finance to ensure mining operations provide a lasting economic and environmental legacy for host communities after extraction ends. By using capital to enforce a responsible mining sector, institutional investors provide the physical security required for a functional, low-carbon economy.